So we discussed this topic, empirical and molecular formula, yesterday. The empirical formula, the formula which represent the simplest ratio between the atoms, whereas molecular formula represent the actual number of atoms. And how we can find the empirical formula? From the mass or the percentage. So if in the question they provide you the mass, so if we have the mass or the percentage, then we will follow three steps. What are the three steps? Number one, we will divide by atomic mass. That will be step one. Step two, we will divide by the smallest value. And step three, we will write the ratio in whole number. So that will be our third step. We'll write all the ratios in whole number. So we'll do some examples, more examples related to that. So these are some questions related to empirical and molecular formula. In the first question, they mentioned determine the empirical formula of a compound with a composition 48% carbon is there, 4% hydrogen is there, and 48% oxygen. So we'll solve this question, a compound which is having 48% carbon, 4% hydrogen, and 48% oxygen. So we have carbon, hydrogen, and oxygen. That is 48%. Hydrogen is 4%. That is given, and oxygen is also 48%. Now, what is step one? Step one is divide by atomic mass. So how you can work out the atomic mass? For that, you have to use a periodic table. As you can see, this is a periodic table which will be there in exam. So what is the atomic mass of carbon? Atomic mass of carbon. So carbon is 12 atomic mass. What about oxygen? The mass number or atomic mass of oxygen, that is 16. And for hydrogen, that is 1. So these are the atomic masses of carbon, hydrogen, and oxygen. And this is our question, the first question we are doing. So first step, divide by atomic mass. So this will be divided by 12, this will be divided by 1, and this will be divided by 16. So 48 divided by 12, that's equal to 4. 4 divided by 1, that's equal to 4. And 48 divided by 16. That is equal to 3. So that is step 1. Then step 2, we'll divide by the smallest value. So what is the smallest value? In this example, the smallest value is 3. So we'll divide all of them by 3. So 4 divided by 3. That's 1.33. 4 divided by 3, 1.33. And 3 divided by 3 is 1. So this is now the step 3. We want all of them in the simplest whole number, simple ratio in the whole number. So whenever one of the values 1.332, so what we will do, if it is 1.33, we'll multiply all of them by 3. If it is 1.5, 2.5, 3.5, we multiply all of them by 2. But in this example, because if I multiply 1.33 by 2, it will not make a whole number. Like it will be 2.66, this will be 2.66, and this will be 2. But that's not the whole number. But when I multiply 1.33, so whenever one of the values is 1.33, we multiply all of them by 3. So when we multiply, it will be like 3.99, which is approximately equal to 4. This is also 3.99, which is approximately equal to 4. And this will be 3. So what will be the formula? This contains C4, H4, and O3 as a simplest ratio. Is it clear, this example? Yeah, we can multiply. Look, basically what we have to do, we have to multiply by the smallest number, which will convert them into a whole number. So if we multiply by 2, after 2 we have next number 3. So if we multiply them by 3, that when we multiply them by 3, 3 will convert them into the nearest whole number. So we can multiply with any number, but that number should be small. Like we first check whether if I multiply this by 2, whether it convert into a whole number. Then I multiplied by 3, whether it convert into a whole number. Then I multiplied by 4. So we will check according to the number, like which one is converting it to whole number. Is it clear, this example, to everyone, how to work out the empirical formula? Now we'll do question 2. Yeah, it will come as 3.99 when you're multiplying 1.33 by 3, that is giving 3.99, and 3.99, the whole number, it is completely rounded off to 4. Okay, question 2. Now we have question 2, a compound. We have to determine the empirical formula, the composition of the compound. It contains carbon, it contains hydrogen, it contains nitrogen, and it contains oxygen. How much carbon is there? That's 36. The mass can be given or percentage can be given. How much hydrogen is there? 4%. Nitrogen is 28%, and oxygen is 32%. And the atomic masses, in exam they will not provide you the atomic mass, but you will have the periodic table. So using a periodic table you can work out the mass, that carbon is 12, nitrogen is 14, oxygen is 16, and hydrogen is 1. So we have carbon, hydrogen, nitrogen, and oxygen. Carbon is 36%, hydrogen is 4%, nitrogen is 28%, and oxygen is 32%. First step, we divide by atomic mass. So carbon is 12, hydrogen is 1, nitrogen is 14, and oxygen is 16. What's the answer? 36 divided by 12, so that our answer will be 3. 4 divided by 1, our answer will be 4. 28 divided by 14, our answer will be 2. And 32 divided by 16, our answer will be 2. That is the step 1. Then our step 2, we divide by smallest value in the combination. So what is the smallest value in the combination? The smallest value is 2. So we divide all of them by 2. So 3 divided by 2, that will be 1.5. 4 divided by 2, that's 2. 2 divided by 2, that's 1. And 2 divided by 2, that's also 1. Now, step 3, we want all the ratios, all the ratio in whole number. But one of the values is 1.5. So if any one of the values 1.5, 2.5, 3.5, what we do? We multiply them all, and we multiply all of them by 2. So we'll multiply this by 2, 2, 2, and 2. So we multiply all of the numbers by 2. So this will turn out to be 3. This will be 4. Then 2 multiplied by 1, 2, and then 2. So this compound, empirical formula of the compound, it contains 3 carbon in the ratio, 4 hydrogen, 2 nitrogen, and 2 oxygen in the simplest ratio. So the answers are given in the question, and this exercise answers are given, but how to work out the answer, that is important. Is it clear, this question? To everyone? Just Heather, Mirab, Saim. Is it clear to everyone? Discussion. Then how to find the molecular formula from empirical formula. So if empirical formula is given and we want to find the molecular formula, so that is the relation is the molecular formula is equals to empirical formula multiplied by n. So molecular formula is equals to empirical formula multiplied by n. And what is value of n? N is equals to molecular mass divided by empirical mass. So I will solve an example so you will understand how it can be done. From empirical formula, how we can find the molecular formula. So the relation between molecular formula and empirical formula, that molecular formula is empirical formula multiplied by n. And what is the value of n? N is molecular mass divided by empirical mass. So if the question is molecular mass of compound is 60 and empirical formula is CH3, find its molecular formula. That's a question example. Yeah, they will provide or they will give you the molecular mass. Now, that's an example that molecular mass of a compound is 60 and empirical formula is CH3, find the molecular formula. So we can say molecular formula is equals to empirical formula multiplied by n. Here empirical formula is CH3. But what about n? What is the value of n? N is equals to molecular mass divided by empirical mass. So what is the molecular mass? The molecular mass is given 60. What about empirical mass? What is empirical mass? How to get the empirical mass? Empirical mass you will find from empirical formula. If empirical formula is CH3, what will be empirical mass? So carbon is 12 multiplied by 1 because one carbon is there plus hydrogen is 1 multiplied by 3. So there is one carbon atom, mass of carbon is 12 and only one carbon atom is there, that's why it is 12 multiplied by 1, plus there are 3 hydrogen, so and each hydrogen is having a mass of 1, that's why it is 1 multiplied by 3, so total will be 15. So empirical mass is 15, so it will be 60 divided by 15. What is the answer for 60 divided by 15? That's equal to 4. So the value of n here is 4. So it will be CH3 multiplied by 4. So CH3 is multiplied by 4. What it will become? It will become C4NH12. So the molecular formula of this compound is C4H12. Is it clear? This example? So basically you have to memorize this formula which relate the molecular formula is empirical formula times n, and the value of n is molecular mass divided by empirical mass. How we multiply, it is written CH3 and then it's a bracket 4. So this 4 is multiplied with carbon. So 4 multiplied by 1, that's why 4 carbon. And 4 is multiplied with hydrogen 3. So 4 multiplied by 3, that is 12. This number 4 is multiplied with each atom. That's why 4 multiplied by 1 is 4 and 3 multiplied by 4 is 12. Another example, molecular mass of compound is 48. Find and its empirical formula is CH4. Find its molecular formula. So to get the molecular formula, we should have the empirical formula and how they are related with each other. We have this formula that molecular formula is equals to empirical formula times n. So molecular formula is equals to empirical formula CH4 multiplied by n. What is the value of n here? How to get the value of n? N is molecular mass divided by empirical mass. So molecular mass, that's 48. But what about empirical mass that you can get from empirical formula? So one carbon is there, that's 12 plus there are 4 hydrogen. Each hydrogen is having a mass of 1. So 4 multiplied by 1, that's equal to 4 plus 12, total 16. So it will be 48 divided by 16, that's equal to 3. So value of n is 3. So here value of n is 3. So this 3 is multiplied with carbon and this 3 is multiplied with hydrogen as well. So the formula, the molecular formula is C3H12. Is it clear this example to everyone? So now we'll do some examples related to the molecular formula. So this is a question. In this question, actually, we have to find both empirical and molecular formula. So first we'll determine the empirical formula, and from empirical formula we'll determine the molecular formula. So they mention in the question, determine the empirical formula of a compound. So that's the first part of the question, because both parts are related to each other. Without empirical formula, we cannot find a molecular formula. Uh, with the composition 48% carbon. So first we are finding the empirical formula. That's the first part of the question. So we have carbon is there, hydrogen is there, nitrogen is there, and oxygen. A compound contains 48% carbon, 8% hydrogen, 28% nitrogen, and 16% oxygen. So first step, we divide by atomic mass. So we divide by 12. This we divide by 1. Nitrogen divided by 14 and oxygen divided by 16. So 48 divided by 12, that's equal to 4. This will be 8. This will be 2, and this will be 1. Then the third step is divide by the smallest value. So smallest value is already 1. So it actually they are already in the simplified form. As the smallest value is 1, so we divide all of them by 1. So it does not make difference to the final answer. This will be 4, 8, 2, and 1. So the empirical formula of this compound, it contains 4 carbon in the ratio, like the simplest ratio between the atoms. 4 is to 8 hydrogen is to 2 nitrogen and 1 oxygen. That's the empirical formula. That's the first part. Now the second part, if this compound has a molecular mass of 200, what is the molecular formula? So how to get the molecular formula? We have molecular formula is empirical formula times n. So we have the empirical formula, which is C4 H8 N2NO. But what about n? So how to get the value of n? About the n, we know n is equals to molecular mass divided by empirical mass. Molecular mass is 200. What about empirical mass? Empirical mass from empirical formula. So that will be, because 4 carbon atoms are there, so it will be 12 multiplied by 4, which is 48, plus 8 hydrogens are there, multiplied by 1 into 8, that will make 56. Then 14 multiplied by nitrogen is 14 multiplied by 2, plus oxygen is 16. So the total sum, 48, 56 it will be, plus 28, 16. The total sum will be 100. So value of n, 200 divided by 100. So value of n is equals to 2. So value of n is 2. So this 2 is multiplied with all. It is multiplied with carbon, multiplied with hydrogen, multiplied with nitrogen, and multiplied with oxygen. So what is the final answer? It will be C8, H16, N4, and O2. Is it clear, this example? The molecular formula of the compound. So using the empirical formula, we worked out the molecular formula. Any doubt in this part? How to get the value of N? As this was the question, we were having the empirical formula that it was C4H8N2NO. That was empirical formula. And molecular mass is given. That was given 200. So we need molecular formula. The molecular formula is equals to empirical formula multiplied by N. The empirical formula is C4H8N2NO. What about value of N? The value of N is equals to molecular mass divided by empirical mass. The molecular mass is given 200. That's given in the question. How to get the empirical mass? So empirical mass you can get from empirical formula. So there are 4 carbon atoms and mass of each carbon is 12. So that is why 4 multiplied by 12. Plus there are 8 hydrogen atom and mass of each hydrogen is 1. So 8 multiplied by 1. Plus there are 2 nitrogen atom and mass of each is 14. So 2 multiplied by 14. And there is only 1 oxygen, so that's why it is 16. So when you solve this, 12 into 4, 1 into 8, 2 into 14 and 16, when you add them all, your total sum will come out as 100. So the empirical mass is we will get from empirical formula, so that is equals to 100. So 200 divided by 100, what is the value of N? Value of N is 2. So if this value of N is 2, this 2 is multiplied with all the atoms. So it will be C8H16 N4NO2. Is it clear? So another similar question. Determine the empirical formula of a compound which is having 60% carbon, 12% hydrogen, and 28% nitrogen. So first we have to determine the empirical formula. We have carbon, we have hydrogen, and we have nitrogen. It is having 60% carbon, 12% hydrogen, and 28% nitrogen. The first step, we divide by atomic mass. The carbon atomic mass is 12, hydrogen atomic mass is 1, nitrogen atomic mass is 14. 60 divided by 12, that's equal to 5. This 12 divided by 1, it will be 12. And 28 divided by 14, that's equal to 2. Then this was step 1, we divide by atomic mass. Step 2, we divide by the smallest value. So which one is the smallest value in the combination? 2 is the smallest value, so we divide all of them by 2. So this will be 2.5, this will be 6, and this will be 1. Whenever one of the values 1.5, 2.5, 3.5, so what we do, we multiply all of them by 2. So we'll multiply all of them by 2. So this will be 5, this will be 12, and this will be 2. So the empirical formula of the compound is C5H12 and N2. Now the second part, we have to find the molecule. The molecular mass is given 30, and we want to find the molecular formula. So molecular formula is equals to empirical formula multiplied by n. So we have the empirical formula, which is C5, H12 and N2. How to get value of n? The value of n is equals to molecular mass divided by empirical mass. The molecular mass is 300. But what about empirical mass? So empirical mass we can find from empirical formula. So empirical mass, because 5 carbon atoms are there, multiplied by 12, each carbon is 12 plus, so that will make 60. 12 hydrogen are there, multiplied by 1, so total will be 72, plus 14 mass of each nitrogen is 14 and there are 2, so it will be 2 multiplied by 14. So when we work out, this will come out as 100. So empirical mass is 100. So 300 divided by 100, value of n is equals to 3. So here the value of n is 3. So this 3 is multiplied with carbon, multiplied with hydrogen and multiplied with nitrogen. So what it will be, 3 multiplied by 5, 15, hydrogen 12 multiplied by 3, 36, and nitrogen 3 multiplied by 2, that's equal to 6. So that is the molecular formula of this compound. Is it clear? So this is how we work out the molecular formula from the empirical formula. Another example. So a rock is containing a magnesium compound. It's having uh, 2.73 grams of magnesium. It is having 1.58 grams of silicon, and it is having 3.60 grams of oxygen. We want to find the empirical formula. So what will be our first step? Divide by atomic mass. So using a periodic table, you will find the atomic mass of magnesium is 24, silicon is 28, and oxygen is 16. So 2.74 divided by 24, that will come out as 0.1137. 2.73 divided by 24. Then 1.58 divided by 28, that will be 0.05864. And then 3.6 divided by 16, that's equal to 0.23. Then we divide by the smallest value. So what is the smallest value in the combination? Which one is the smallest value? 0.05. So 0.05864 is the smallest value. So 0.11375 divided by 0.05864, that will give 1.93 or 1.9. This will be 1, and 0.2 0.23 divided by 0.05864, that's equal to 3.9. So like 1.9, 2.9, 3.9, so we don't multiply, we just round it off to the nearest whole number. So when you, this will be 2, this will remain as 1, and this will be 3.9 will be 4. So what is the empirical formula? It will be MgSiO4. Is it clear, this example? Because it is 1.9, 2.9, 3.9, in that case, the nearest whole number is there. So we just convert them into the nearest whole number. If it is 1.5, then we multiply by 2. If it is 1. Yeah, Mg is 2. I wrote 1 here, but Mg is 2, so it will be Mg2 SiO4. Is it clear, this example? So this is a question basically from the past paper. So in this session we discussed how to find empirical as well as molecular formula from the percentage, or but most of the time you will find empirical formulas rather than molecular formula. But because that's a part of the syllabus, so you should learn uh, how you will find both of them.